So this follows on, but we've arrived at a formula. We've derived a formula. And how do we, let's just recap, how did we do that? What were we doing? We particularly looked at the curve y equals x squared, and we had 2 points, and we were moving them closer and closer and closer together to find the instantaneous slope, right? In fact, we went on to find the slope function, a function that tells us the slope for any value of x, all right? And so this is the formula. What we have a function, we can call it y, sometimes we call it f of x. We arrived at what we call the derivative function, or sometimes also known as the slope function. And this is denoted as dy on dx, all right? The rate of change of y with regards to the rate of change of x, or f dash of x. That's how we notate it. And this is the formula here. If this is the function, then the derivative function is this formula. That's what we're going to be applying now. So we have a function here, x squared plus 3x. So we're on to 11 there, using first principles. So we've got the derivative function on first principles. Here's the table, all right? We've got some notation down there. And then here we are for question 11. So you don't really need to know how we arrive at the formula, all right? The most important, taking a pragmatic approach, the most important part is how to use the formula, all right? But that first lesson's a bit of background knowledge, shows you how we arrive at it. Let's get into using the formula. Here's a function. We want to find the derivative function, and we're going to do so using our first principles formula. So the first step is to find, set it up, okay? F dash of x is equal to the limit as h approaches 0 of, okay, the first part is f of x plus h. So that's where we take x plus h and we put it into the function. So I'm going to put it there and I'm going to put it there. All right, f of x plus h, maybe I'll write it out and then show you the simplification. F of x plus h, we put x plus h there, so we'll have x plus h squared plus 3 times x plus h. Okay, this whole part is f of x plus h, right? All we've done is taken x plus h and substitute it into the f of x function. So look at the formula, f of x plus h, take away, okay, so take away f of x, all right? Now what is f of x? Well, it's just x squared plus 3x. That's the function we're talking about at the moment. We have f of x plus h, take away f of x. F of x must be in brackets because this negative is going to distribute. Must be in brackets, okay? So all of that, f of x plus h, take f of x, divided by h. So that's step 1. All we've done is plug this function into the formula. Once it's in the formula, all right, it's just a matter of expanding, collecting like terms, cancelling h, and applying the limit, okay? Now, whenever we have a limit occurring, we must state it in every step until we apply the limit. So this is going to belong to everything until we apply it. So in the next step, what I'm going to do is expand everything here. All right, and I'll do it in, I think, one step. Hopefully we're pretty comfortable with the perfect square expansion. This one is a perfect square, x squared plus 2xh plus h squared. This one is going to become 3x plus 3h. And then we have take away x squared and take away 3x, all on top of h. Okay, look along, we'll cancel what we can. We're going to collect the like terms, the terms that have the same value. So I'm looking, I've got x squared and minus x squared. Cancel. I've got 3x and minus 3x. Cancel. Okay, let's restate everything that we have. We've got 2xh plus h squared plus 3h on top of h. Now, there's a point where you can check if you've done the right thing. At this step, everything you've got left with must have a h in it. There's a h there, there's a h there, there's a h there, and there's a h in the bottom. Everything's got a h in it. We've satisfied that. We're ready for it to factorise and cancel the h. Okay, so what do? We put it in the formula, expanded, cancelled like terms. Now let's factorise that h. Factorise the h and cancel it. It's at the top and the bottom. So we're left with 2x plus h plus 3. That's what we've got. And now we can apply the limit. Okay? So applying the limit means it simplifies to 2x plus 3. That h term is going to 0, right? So we're left with 2x plus 3. So we found f dash of x, that should be f dash of x. F dash of x is 2x plus 3. So let's write this up. We've got f of x is x squared plus 3x. F dash of x is 2x plus 3. Okay, this is the function. What does the function tell you? The function will tell you the y value for any value of x. If you put the number 1 into the function, it tells you the y value when x is 1. If you put the number 2 in, it tells you the y value when x is 2. How about this one? This is the derivative function, the slope function. It tells you the slope, how steep the function is for any value of x. You put the number 1 in, it's going to tell you how steep it is when x is 1. You put the number 2 in, it tells you how steep it is when x is 2. That's what they mean. Now, it says, using first principles, find the slope function, and hence find the y-coordinate and slope when x is 3. Okay? So what that means is we want to know the y value when x is 3, f of 3. We put the number 3 into the function. We'll have 3 squared plus 3 times 3. So we have when x is 3, y is 18. We'll put 3 into the slope function. We'll have 2 times 3 plus 3. So it's going to be 6 plus 3, 9. And so what we have then is when x is 3, y is 18, and the slope is 9. Okay? So just differentiating, the function tells you the y value, the slope function tells you the slope, tells you how steep it is. Alright, so we've got B and C to do there using the first principles process. You're very welcome at any stage to stop listening to me and go ahead and have a go at B and C. I'll definitely go through B now. And then see how we're feeling about C. So, clear this off. So for B, the function we have is x squared, take 2x, plus 4. Let's put it into the formula. First, we need f of x plus h. That means we put x plus h everywhere there's an x. So it'll be that's just the f of x part, right? F of x plus h part, that's just that part. Then we have take away, and we're taking away f of x. What is f of x? This is the function. All on top of h. So f of x plus h, take away f of x on top of h. Step 1, put it in the formula, done. Step 2, completely expand. Expand everything. So remember, we have to keep the limit. You'll get marks taken off if you forget to write the limit. So the first one's a perfect square. Minus 2x minus 2h. The negative belongs to the 2. Alright, so a fully expanded f of x plus h. Then we distribute the negative into f of x here. So, step 1, formula. Step 2, expand. Step 3, collect like terms. Alright, we've got x squared minus x squared. We've got minus 2x and plus 2x. We've got 4 and minus 4. Okay, let's restate what's left over. We have 2xh plus h squared. Take 2h. Everything has a h in it. Alright, we're affirmed. That means we've done the right thing so far. Factorize the h and cancel it. Okay, so we've found the slope function, right? That's the slope function. Sorry, Kev.
That is step 2, the last part. No, the step 2, after we expand the thing. Yeah.
Yep.
Is it the plus 2x minus 4?
Plus 4 minus 4. Yeah. Yes, because negative. Yep. Good question. Yep. So that negative, you need to make sure that distributes there. Yeah, very good. And everything will cancel. So if you haven't done it right, you won't be able to cancel it down. Okay, so we got the slope function right. So that's the derivative function. That's our main skill here. Okay? Just taking it a little bit further for comprehension. Find f of 3. Alright? When x is 3, we get the y value is 7. When x is 3, we get f dash of 3 is 4. The slope is 4. So that's how steep it is for that x value. Alright, I would like... I reckon I would like to put in one more before I get you to have a go at C. I'm going to put in, like, let's call it question B.5 or something. a halfway point. So just before we jump up to C and have a go at that by ourselves, let's have a go at this one. And we'll call it f of x is x squared plus 2x, take 3. Let's get you guys to have a go at this question by yourself, okay? So I want you to find the slope function, perform this beautiful methodical process, get the derivative function, and then sub in 3, see how you go.